Greetings! I would like to quickly introduce myself. My name is Nur Hidayah binti Hazli, and I'm going to present about the introduction for this video. Let's get started! Mankind is generally going through different stages of life and encountering numerous circumstances in daily activities. People occasionally have a very high instinct to determine how the world works around them and discover the unsung mysteries that have been buried for years. Mathematics and sciences are a good combination of finding the best solutions to those questions which have been utilized or applied centuries back then by archaeologists, scientists, mathematicians, and others. Nowadays, the application of first-order differential equation is necessary in order to predict accurately and produce the best outcomes of the unsolved problems. The first-order differential equation is clearly expressed by an equation that can be jotted down as below. Y prime equals to a function of variable x and y, or dy over dx equals to fxy, in which two variables, namely x and y with its function fxy, defined on a region in the xy plane. The equation shown is of first degree because it includes only the first derivative, specifically dy over dx, and no higher order derivatives exist. Furthermore, it is widely used to express a relationship between the function and its derivatives. This equation can be classified into 5 different types, for instance, linear differential equations, homogeneous equations, exact equations, separable equations, and eventually integrating factor. The characteristics that can be identified from the first-order differential equations are the products of y and any of its derivatives are not present, and it does not have any transcendental functions such as logarithmic functions and trigonometric functions. In a few subjects such as chemistry and physics, the application of the first-order differential equations is essential in ascertaining the answers to various curiosities. Some of the applications which implement the first-order differential equations are Newton's law of cooling or heating, exponential radioactive decay, electrical circuits, mixture problems, exponential population growth, orthogonal trajectories, and falling body problems. This equation is also applied to engineering systems, modern natural phenomena, and countless situations.
Among the 5 concepts of application of first-order differential equation, mixture problem has been chosen as our case study. In this case, we are going to analyze the issue of polluted river in Selangor. Throughout 2020, Selangor has recorded 9 polluted rivers and 8 critical disruption of water supply cases. According to the state government, majority of the incidents happen due to irresponsible action by a number of industrial factories. For instance, illegal release of industrial effluents and toxic waste into rivers. This never-ending issue has affected an estimated of 5 million people in Selangor and Kuala Lumpur, as they had to suffer on repeated water cut-off. Since water is considered as a basic necessity, hence it is essential for the authorities to enforce stricter law and regulation. This crisis needs to come to an end, and those environmental criminals should be punished accordingly.
Now, we are going to do some calculation to find the equation that describing the amount of industrial waste in the river at any time t, and also to determine the amount of industrial waste in the river after 2 days. Before that, let's go through to some informations of this problem. First, the initial solution of the river, which is V naught, is equal to 20,000 cubic meter. Second, the amount of initial substance in the river, A naught, is equal to 250 kg. Next, the inflow rate of the industrial waste released by the factory, R1, equal to 1000 cubic meter per day. It has the same amount as the outflow rate of the river entering the sea nearby. Lastly, the concentration of the inflow rate C1 is equal to 100 kg per cubic meter. Meanwhile, for the concentration of the outflow rate, C2 is equal to AT over VT. So now, let's answer the question A, which is find the equation describing the amount of industrial waste in the river at any time t. The first step that you need to do is to find the VT. VT is the total of initial value of solution in the river plus volume of solution entering minus volume of solution leaving. Here is the equation of VT. And then we substitute the V naught, R1 and also R2. So we get 20,000 cubic meter plus 1000 T minus 1000 T equal to 20,000 cubic meter. Second step that you need to do is to find the dA over dt. So first, let the AT be the amount of industrial waste in the river at any time t. How to find the dA over dt? The dA over dt can be found by subtracting the output rate of industrial waste from the input rate of industrial waste. And then substitute the C1 R1 and the C2 R2. Hence, we get 100 multiplied by 1000 minus AT over VT multiplied by 1000. Don't forget to substitute the VT because we already calculated it before. After we simplify the equation, we will get 100,000 minus 1 over 20A. Therefore, the model is dA over dt plus 1 over 20 multiplied by A equal to 100,000. And the initial substance in the river is 250. The next step that you need to do is the integrating factor. From the previous calculation, we know that dA over dt plus 1 over 20A equal to 100,000 is already in linear form. How to find the PT? You can find the PT by comparing the PXY with the model. Therefore, the PT is 1 over 20. After that, solve the integration. As soon as you get the integrating factor, you need to multiply the integrating factor to both sides of the equation. For the step number 5, you need to integrate both sides of the equation. Hence, you will get AT equal to 2 million plus C multiplied by E to the power of negative 1 over 20T. For the final step, you need to apply the initial condition given, which is A naught equal to 250 in order to find the amount of C. From the previous calculation, we get AT equal to 2 million plus C multiplied by E to the power of negative 1 over 20T. Now, substitute the T with 0. And then solve the equation until you get the amount of C. Substitute the amount of C into this equation. Thus, the equation describing the amount of industrial waste in the river at any time t is AT equal to 2 million minus 1,999,750 multiplied by E to the power of negative 1 over 20t.
Now, we will be continue by answering question B. Question B asks us to determine the amount of industrial waste in the river after 2 days. How to calculate the amount of industrial waste after 2 days? Let's solve this question together. In order to answer this question, we will go step by step. So step 1 is Since the question asks for 2 days, therefore our t is equal to 2. Step 2. By using the equation that we got from question A, we will substitute t is equal to 2 and solve it. The equation will look like this. A of t is equal to 2 million minus 1,999,759 times exponent negative 1 over 20 times t. Substitute t is equal to 2, then we will get the answer 190,551.3733. Therefore, we can conclude that the amount of industrial waste in the river after 2 days is 190,551.3733 kg.
Lastly, I'm going to talk about the conclusion of our report. As a conclusion, mixture problem applies the techniques and theory to solve a differential equation. The problem that needs to be solved can give us information based on the concentration of a substance. Just as what we have done with our report, we choose to analyze mixture problems on the flow of polluted river. Based on the report, we found out that there were a lot of industrial waste that affects the river. This proved that there was an extreme pollution in the river for the past 2 days. The toxicity of the chemical substance from the industrial waste had caused a lot of damage, especially towards the habitat in the water. By analyzing its mixture problem, we had managed to identify the amount of polluted substance that had mixed with the river and determine its problem accordingly. Besides, we were able to investigate the real reasons of the river pollution in the first place. As the river was polluted by the industrial waste, the responsible authority should take immediate action by conducting inspection at every factory that might release their industrial waste in the river. For example, they can take legal action by providing legal suits or give warning to the factory. This act can be one of the reasons for us to prevent any pollution to happen in the future. Other than that, people also can take appropriate measure by becoming more aware of the pollution river issues. Therefore, we can say that there are a lot of advantages when we conduct mixture problems. It gives us a clear view towards the problem and makes us realize its causes. With that, we can be more alert towards certain problems that involve mixture substance and solutions. So, mixture problem of differential equation is a suitable application that can be used to solve the polluted river problem. That's all from us. Thank you for your time.